Okay, guys, we just did an inequality investigation, and what did we discover? Most of the time, statements were true. When you added both sides, did you still have a true statement?
Yeah.
When you subtracted something to both sides, did you still have a true statement?
Yeah.
When you divided or multiplied each side by a negative, did you still have a true statement? No. It was false. If you multiplied and divided by a negative. What if you multiplied or divided by a positive? It was true. So what we have to remember is that if we divide, all right, if we divide or multiply by a negative, it's going to cause the inequality to be false. So what we have to do is, and now we didn't do this in the investigation, but what we have to do is that we have to switch the inequality sign. All right, so let's do an easy problem. Let's do an easy problem. 2x is greater than 8. This is very easy. I solved the problem by doing what to both sides. Divide by 2. Now, when we divided by 2 in our little experiment, our little investigation, did we still have a true statement?
Yeah.
Yeah, so we don't have to do anything here. Our answer is x is greater than 4. Now, let's do another easy problem. 2x is greater than negative 8. Once again, I'm still dividing by a positive, so I still don't have to change anything. X is greater than negative 4. Now, I'm going to throw a curveball at you. Negative 2x is greater than 8. What happens when we divided the negative in our little experiment, a little investigation? It became a false statement. So what we learn here in my little brief introduction, we have to flip this sign. So instead of it being greater now, it's now less than negative 4. There's my answer. Questions on these problems? Yes, Jay.
Are you only switching the sign whenever you divide?
I'm only switching the inequality sign when I divide by a negative. So when I divided by a positive, I left the sign the same. I divided by a positive, I left the sign the same. I divided by a negative, I switched the inequality sign. All right? Next problem. Next problem. X divided by negative 3 is greater than or equal to 9. What do I got to do to both sides? Multiply by negative 3. Now, what happened in our little investigation when I multiplied by a negative? It was a false statement, so I have to flip the sign. So x, flip the sign, less than or equal to, answer, negative 27. Does this make sense? So this is a couple simple problems on how and when I flip the sign. Next page, we're going to do a couple harder problems. Now, 2x plus 7 equals 21. Step 1, subtract 7. Subtract 7. Answer, 2x equals 14. Oh, time out. This whole lesson is about inequalities. Reminder, let me put an inequality in there. How about I put in less than or equal to? Now, when I subtract 7, do I need to flip the sign? No. So I leave the inequality the same. Now, how am I going to finish my problem? Divide by 2. What's my answer? Oh, do I got to flip the sign? No. X is less than or equal to 7. Another problem. Here we go. X divided by negative 4 minus 5 equals inequalities, less than or equal to 15. Step 1, add 5. New inequality, x divided by negative 4, less than or, should I flip the sign?
No.
No. 20. Next step, multiply by negative 4. Do I flip the inequality? Yes. All right. X is greater than or equal to negative 80. So do you understand? We've done some simple problems that it only involved one step to solve the problem. We did some harder problems that involved 2 steps to solve the problem. And you should see exactly when we flip the sign is when we multiply or divide by a, I forget, tell me, multiply or divide by a negative. Question. All right, we're done with the lesson. We're going to go to some practice problems.